And we're back. So what is displayed in front of me is a bit of homework from my class. So to end this video, I think, to end my learning section 59, I think I'm just gonna do question 7B and all the way to IV. And situation, I don't care. The rest of it, I'm too tired for this. It's 11:36 right now, and I have a lot of other stuff to do. And I was probably gonna upload another video after this, so everything's gonna be fine. So let's fill this up, shall we? Let's decrease this back to 16. So state the nose laws in words. And I just wrote this off camera while grabbing all the stuff, taking a small break, listening to one song or two. So in my description, the nose law is a formula to explain the relationships between the angles of index and refractions in the topic in the area of light waves when traveling between two mediums. And I think a lot of people would agree with me for that. And there you go. Nice. Angle refraction. So what do we know? So no. So index. Actually, how do I explain it? Yeah, sin. Forgot sin. Everything's sin around here, isn't it? So sin. What? Yes, sin. Oh. And we tried the refraction. What else do we know? Not much really. So in this situation, I guess one of the things we can do is to list out the things that we have right now. So B. So you know, sin 1 is equivalent to 30 degrees. Alpha equals 5.80 times by 10 centimeters. So I know it's since the density of the air is lighter, this is denser. It's probably going to travel along this direction. If I just find a new angle, so N equals C over V. Alright, do we know V? V equals frequency over alpha. I think that's called alpha. I don't remember. So sin 1 equals sin L equals V over 1 over V over 2 equals to N over 2 equals N over 1. N equals to C. So N over 3 times 10 by the power 8. Let's rearrange this. So we want to find V. And V equals C. So V equals C divided by N. So give us, that gives 3 times 10 power 3 power 8 over 1.33. And that'll give us a velocity of about 225,63909.8 meters per second. So now we get V2 as well. Nice. V1 will be equal to C. So therefore, by using this formula, we conclude that So sin alpha and sin reflective, okay, equals C over V. Wait a second. Look at the formula again. Yeah, C over V. So when you find LR, sin R over sin alpha equals V over C. Sin R equals V over C. Yeah, V over C times by sin I. Which means that sin R is equivalent to 225563909.8 over 3 times 10 by the power 8. And then I want to times by sin 30. Approximately 7.5211 times it by sin of 30, which is 0.5. So we essentially have 7.72 times by 0.5, and that has 3.7607 degrees. And this will be quite simple, really. So right, estimation of 30 minus 3.76, and that will equal 28.24, I think. 28. So we know sin I, sin R. We know C, speed of light underwater, and with the surface of the water being n, we use n and straight C over V. Yeah, we knew that. C over V. Then we change the formula to find V. So yeah, we got it right here. Then that makes me question though, how would you do the other one then? There has to be another formula, I guess. Well. The point is we got the answer. Right. Here. That is the number 225563909. 9.8. Yeah. Okay. Sin I, we know sin R. We know original wavelength. So alpha 1 equals 5.80 times 10 by 7. So we got that. Minus 2. Oh, that's pretty easy. This one's pretty easy too. So that's sin I over sin R equals alpha 1 over alpha 2. Okay, what was the formula? Sin reflection, so that's about 3.76 over sin 30 times it by 5.80 times it by 10 of the minus 7. So we get about an estimate of 7.6 times it by about 10.